Well, hi, guys. So, hey, in this lesson, we're going to talk SFPs. That sounds exciting, doesn't it? Yes. So, small form factor pluggable, or SFP devices. These are hot swappable interfaces used primarily in networks and storage switches. So, the SFP ports on a switch and SFP modules will enable the switch to connect to fiber and Ethernet of different types and speeds. Now, there is actually a committee, right? The Small Form Factor Committee. This is a group consisting of major equipment vendors. They created the SFP specification, first published in 2001. Very important step, though. SFP modules built to the initial specifications support data rates of up to 1 gigabit. Now, the specification has since been updated to support increased data rates like we see today. Now, almost all enterprise-class switches include 2 or even more SFP ports, enabling them to become part of a ring or star-based network topology, spread among different buildings, floors, or areas, connected via fiber optic. Okay? Now, you can always find an SFP port on a network device, such as a switch, server, router, or network interface card, or even a computer. Most switches used in large computer network applications have at least 2 SFP ports. Now, these switches are sometimes referred to as SFP switches. So, an SFP port connection enables a transfer of data between 2 devices via this SFP transceiver and appropriate cabling. So, in other words, the port and its corresponding SFP transceiver allow the 2 devices to communicate with each other over an extended distance. So SFP module types support both single and multi-mode fiber, as well as Cat5, Cat6, Cat6A, and Cat7 twisted pair copper. SFP modules designed for use with fiber support a variety of wavelengths and maximum distances, up to 2 kilometers with multi-mode and 40 kilometers with single mode. Now, connections using Cat6A are limited to approximately 100 meters, but crosstalk between adjacent cables can limit actual maximum distance. Cat7 cables include additional shielding to reduce crosstalk, but they can be difficult to install due to the increased cable thickness. Then we come to enhanced SFP, or SFP+. So this specification was released in 2006 with a further update in 2011. SFP Plus modules support rates of up to 16 gigabits per second, and like the earlier SFP model, they both support fiber and copper. But see, copper interconnects are limited to 10 meters at 10 gigabits per second. The SFP Plus specification supports single-mode fiber interconnects to 40 kilometers, but some vendors support it up to 80 kilometers. SFP Plus modules are specified for fiber channel, FC, at up to 8 gigabits per second. But again, some vendors support up to 16 gigabit per second data rates. SFP Plus also supports WAN connections based on Optical Transport Network Specification, OTU2. Some SFP modules, such as GLC BXD and GLC BXU, support digital optical monitoring, which lets end users monitor the performance of SFPs in real time, tracking metrics such as temperature, optical output power, optical input power, transceiver supply voltage, and laser bias current. Now, while SFP and SFP Plus modules are relatively inexpensive, 1 gigabit and 10 gigabit connections are more expensive than RJ45 connections. RJ45, of course, uses copper cables, which are generally less expensive than fiber. Also, RJ45 ports are typically built into switches, so customers don't need to purchase any additional parts. Now, the decision of where to use an RJ45 port or an SFP port on a switch depends on the distance between the connection endpoints. If the endpoints are close enough to use copper, then using RJ45 is less expensive. If the distance is great enough to require fiber, then teams should use SFP ports by all means. See, fiber is also a better choice where cables must run side by side for a distance that makes crosstalk between copper cables a big issue. Now, combo SFP ports on a switch. These offer support for both SFP and RJ45 ports using a single interface. Users cannot use both ports simultaneously. I hope that's kind of obvious because only one type will work at a time. But these combo ports enable IT teams to use and choose a connection type that best matches the application, the network, the cost, or distance requirements. You see why planning ahead is so important? All right, so SFP ports can accommodate both copper and fiber optic cable connections. The use of a copper or fiber optic cable depends on the data transfer capabilities of the SFP transceiver. For example, if your network application requires data transfer rates of up to 1 gigabit per second at 100 meters or less, well, you could use a standard Cat6 Ethernet cable with your SFP. The traditional SFP specification created by the Small Form Factor Committee only allows for data transfer rates of up to 1 gigabit per second. And of course, you remember that Cat6 supports a 1 gigabit per second transfer rate as well. So basically, these two are a match made in data communications heaven. Now, if you do need faster transfer rates for your application, you'd of course use an SFP Plus or QSFP Plus transceiver with a fiber optic cable, because these of course could extend much further than 100 meters without sacrificing any performance. The SFP Plus and QSFP Plus specifications support transfer rates of up to 10 gigabits per second and 40 gigabits per second, respectively. Definitely a plus. Now, technically, I suppose you could use a higher category Ethernet cable with an SFP Plus transceiver, but you would be limited to around 30 meters of cabling. Just thought you'd like to know. Now, the vendors out there have continued to update SFP specifications to support higher data rates and additional interconnect types. SFP28 supports 25 gigabit per second over both multimode and single-mode fiber. BiDi SFPs support bidirectional communication over a single fiber, while other SFP types require two fibers, one to send and one to receive. BiDi SFPs use different wavelengths, with one wavelength for sending and the other for receiving data. Pretty clever. Now, compact SFPs support two bidirectional links using the same interface module. So two fibers are used with each carrying bidirectional traffic. Quad SFP, that's where the QSFP comes in. So these QSFP modules support 4 fibers carrying Ethernet, FC, or InfiniBand. Now, most available QSFP modules can support up to 200 gigabits per second. But check it out. We've got octal SFP and QSFP double density, and they have recently become available and extend data rates to 400 gigabits per second. So currently, 400 gigabits per second is the highest rate available in commercially available products. Although, wouldn't you know, work is underway to develop standards and products that support 800 gigabits per second. I mean, why not? SFP technology has demonstrated the ability to evolve as demands increase and will likely continue to evolve to support even higher rates. Exciting future, my friends. So naturally, it's flexible. The SFP port link to the network, right? The SFP port is the I/O device which is able to be hot plugged. We're able to insert gigabit Ethernet port or slot into the SFP port and then connect the SFP port with a network. So the SFP port is applied in many, many products, and it's able to exchange with a port of 1000 base SX, 1000 base LXLH, 1000 base ZX, or even the 1000 base BX10 DU. So, my friends, it's got a lot going for it. But hey, guess what? Time to wrap it up. Now you know all about SFPs. I know you learned a lot, so go and digest that for a little bit, and I'll see you in the next lesson.